Welcome to our lesson today on slope of a line. So just like the title suggests, today all we're going to be doing is to figure out how do we find the slope of a given line on a graph and how can we graph a line using the slope. Alright, so first things first, we talked about rate of change a few lessons ago when we mentioned linear relations. And this is essentially what slope is. Right? The slope is the rate of change of a linear relation, which means that just like the definition of rate of change, it is essentially how much the y value is changing over how much the x value is changing. In, I guess, some buzzword terms, right? This is just rise over run. And it's a lot easier to visualize it on an actual line. So let's take this graph, for example. All right, we got a line here. We want to find out how much this line is changing. And the easiest way to do that is to find 2 points and look at, well, how far away are those points? And importantly, the points should be whole numbers. Right, because there's nothing stopping us from, let's say, doing this point here, this point here. But there's nothing stopping us from doing that, except we don't really know what those 2 points are, right? This is probably around, I don't know, like x is like 2.5-ish, y is 3.5-ish. This one, I've no idea. This could be like probably like 7.54, something like that, right? We don't really know. So when we are looking for 2 points on a graph to find a slope, we want to look for 2 points that are whole numbers, or easy to look at, right? So for example, we can just take this point right here, and this point right there, right? Because from here, this is our y-intercept. So the x is 0, the y is 2. This point right here, we can see that this is 3, and this is 4, right? So x is 3, y is 4. And now we want the changing y and the changing x. So we start from the point on the left and look at how much it changes to the point on the right. So starting here now and going this way, we can see, okay, so to go from here to there, we are moving 3 spaces to the right. Right? So 1, 2, 3. We're going 3 spaces to the right and then 2 spaces up. Right? So we got 3 spaces on the right and 2 spaces up. Therefore, the change in y is 2 and the change in x is 3. Right? So all we are doing here with slopes is just saying, okay, how much are those points changing? And we can see that from here in the y-axis, we're changing by 3. In the x-axis, it's 3. In the y-axis, we're changing by 2. The x-axis, we're changing by 3. Which means that the slope of this fella right here is just 2 over 3. Right? So let's try something else now. Right here, again, we take 2 points that are easy to look at. So let's say this point right here. And how about, let's say this point right here. Okay? So this point, we have x is negative 4, y is 2. This point down there, we got x is negative 1, y is negative 2. Okay, so once again, we look at how much is changing. So going from the left to the right now, we're going down by 1, 2, 3, 4. So we're going down by 4. And we're going to the right by 3. So naturally, the slope will just be 4 over 3, right? Because that's changing y and changing x. All right, so the changing y is 4. The changing x, that's a little over. That's 5. Changing y is 4. Changing x is 3. But we notice that we're actually going down on the y-axis, which means that we are actually going by negatives, right? So instead of saying changing by 4, we are saying changing by negative 4, right? Because y is going down, it means y is decreasing. So we're changing by negative 4 instead. So our slope is negative 4 over 3, just like that. Right? So that's pretty much it. That's how we find the slope of a line. And you might be wondering, do I have to check every single 2 points on a graph? Actually, no. All we need to do is find any of the 2 points. Right? Because if we take the first graph again, and let's do in green now. Let's take this point here, and let's take this point here, right? And we can see to go from this dot to this dot, right? We first go up from 2 to 8, right? So we go up by 6, and then we go to the right by 9, right? Because this point right here is 9, 8, and this point is still 0, 2. Right, so going up by 6 and going to the right by 9, which means that the slope will be the changing y, which is 6, which is positive because we're going up, over 9. Right? And as you can see, when we reduce it, it is 2 over 3. Right? So no matter where you pick the 2 points, as long as it's on the same line, it will always be the same slope. Okay, so that's pretty straightforward. And now how can we go backwards, right? How can we draw a line with a slope of, say, 3 over 5? So we'll get a graph out here. Okay, so from this graph, let's just say we start from 0, 0, because that will be the easiest. Let's do a different color. Start from 0, 0 here. And then we want to go to the right by 5 and go up by 3. Right? Because remember, change in y is the top, change in x is the bottom. Right? So all we're doing here is going up by 3. So 1, 2, 3. And going to the right by 5. So 1, 2, 3, 4, 5. To this point right here. And then connect the line. Okay, that one's a little slightly off, but you get the idea. So all we're doing is following the slope. Right? So the top number of the slope is the numerator, or the changing y value. The bottom number, the denominator, that's the changing x value. So in this case, 3 over 5 just means going up by 3, right by 5. Right? That's all the slope is telling us. It just tells us how much are we changing this line. So now in the next question, we are not really given a graph here, right? Well, we could graph it if we want to, right? Let's just say C will be somewhere around, right? Because C will be somewhere around here, and then D will be like somewhere up here, right? So theoretically, we could just do a graph and then count square by square. But here's an easy way to do this with algebra. Because we're finding the distance between 2 points, all we can do is just subtract one of the points from each other, right? The distance just comes from the subtraction of each point. So all we can do is say we can either do C minus D or D minus C. Right? So let's just do D minus C here. So let's do this point subtracted by this point. And before we start, we notice that, or there's point C and point D, this will form the line CD. Right? This will form a line CD that connects the point C and D. And by finding the slope of the line, we're essentially finding the slope between the 2 points. Right? So let's see. The line of CD will be the change in y over the change in x. And now, once again, we are subtracting the D coordinate by the C coordinate. So we'll take the y coordinate of D, which is 1. Because again, this is the y coordinate on the right, that's x coordinate on the left, right? So take the y coordinate of D subtracted by the y coordinate of C, which is negative 3. Okay? Have the over the x coordinate of D subtracted by the x coordinate of C, right? Just like that. So all we're doing here is subtracting this y by this y right here, subtracting this x by this x, and then putting a fraction, right? 1 minus negative 3 gets us 4, which is 1 plus 3. 2 minus negative 5 is just 2 plus 5, getting us 7. So the slope of this line CD is 4 over 7. So the slope between the points C and D is just 4 over 7, right? So again, you can see this is a lot faster than actually graphing it out, right? So now, what does the slope actually mean, right? What does it even tell us? So we can see here on this graph, Yvonne graphed her biking trip, which you should definitely do just for fun. Right? What is the slope of this graph? Right, we notice that there's not really a line here, right? We're trying to find this hypothetical line here. That will be the slope of this graph. So of course, we can just count, right? You say, okay, so it changes by x by 2, changes by y by 4. Right? So it's easy to say, okay, so the slope must be the changing y over changing x. So 4 over 2, which is 4 divided by 2, which is 2. However, we notice that this graph has a different set of scale. Right? We can see here, in the time, in the x-axis here, we see that for every 2 squares, we get 1 hour. Right? Which means that every half a square is actually only 0.5 hours. And we notice that on the y-axis, right, for every 2 squares, we're going up by 12 each time. Right? Which means that each small square is actually going up by 6. So going from here to here is only going by 1. Because realistically, all we're doing here is going from this point to this point. So going from 1 to 2. And now similarly, we're going from 24 to 48. Right? That's an increase of 24. So the actual slope will be 24 over 1, which is just 24. Right? So this is kind of like, I guess, the quote-unquote dangers of looking at the graph, right? If we use the graph to find our slope, we really have to be careful of the scaling of the graph, right? Because sometimes 1 square means 10, 1 square means 20, whatever, right? Because the graphs we worked with earlier, each of those individual squares are going up by 1, right? -1, -2, -3, -4. Or stuff like 1, 2, 3, 4, right? All of them are going up by 1. But in this graph, it's going up by different numbers. So a more surefire way to do this, or like a safer way to do this, is to just find the coordinates. Now let's take 2 points here. Let's take this point and this point, right? So our first point here, our x is at 1 and our y is at 24. So 1, 24. our second point right here, x is 2, y is 48. So now we just find the change of those 2 points. Right? So let's just subtract this point by this point here. So let's take the y value of the first point. So that's 48 subtracted by y value of the second point. That's 24. Okay, so we're subtracting this right here by this. Okay, and if we subtract x value, so subtract the 2 minus the 1, which gets us 24 over 1, which is 24. Right? So as we can see, using algebra is a lot easier because we can just plot it out. Doesn't matter what the scaling is, right? Whereas with graphs, we have to really think about, okay, this is not going up by 1, this is going up by 5. So now what does the slope represent? Right? So once again, slope is a changing y over changing x, which means that in the context of this equation, or in this question here, the changing y is a change in distance, and a changing x is a change in time. So that's change in distance over change in time. I will notice that the measurement here is in kilometers and hour. If we simplify this massive equation here, all we just get is just kilometers over hour, which means that all this graph is telling us is the speed of Yvonne's bike ride, right? Because, again, kilometers per hour, that's a measurement of speed. And because she's saying that, oh, after 1 hour, she traveled by 24 kilometers. After 2 hours, she traveled 48 kilometers, 3 hours, 72 kilometers, right? We notice here that if she's going at 24 kilometers per hour, right, because that's what the slope is telling us, if she's going at 24 kilometers per hour, by that logic, by hour 4, she will be at 72 plus 24, she will be at 96. It's like here-ish? No, a bit higher. She will be here at 4,96. So in this case, the slope is just telling us kilometers over an hour. So in general, the slope just tells us the y value over x value. When you look at the measurements, you can figure out what it's actually telling us. All right, so with that being said, let's try some practice questions. So pause the video here and try those questions out yourselves before we go over the answers. Okay, hope you had some time to try those questions out yourself. Let's get to it. So, as usual, find the slope of a graph. We'll find 2 points that are easy to work with. So I can see this point right here. Nice whole numbers with -1 and +1, right? X is -1, Y is +1. And this point right here, we get X will be 5, and then the Y will be -1. Okay, so we can either count, or we can see here, first of all, that the graph is going by ones, right? 1 and 2, which means that we can just say, okay, well, this is to go from this point to this point here. We are going down by 2 and going to the right by 6, which means that our slope is just simply slope going down by 2, so it's -2 over 6, which is just -1 over 3. Right? Nice and simple. Algebraically, we can also say, okay, so let's just do this point here, subtract this point. Right? Actually, it doesn't really matter. Let's just do this point this time. So this point here, subtract by this point. So let's say y value, so this y value minus this y value. So you get 1 minus -1. And the x value, this x value minus this x value. Get -1 minus 5. 1 minus -1 is +2. And then -1 minus 5 is -6. And we get -1 over 3 again after reducing. Right? So it doesn't matter which points or which points subtract by which points. As long as you're subtracting 2 points and the y's at the top, x at the bottom, you'll find a slope. Okay? Draw a line with a slope of 5. So in this case, 5 would just be 5 over 1. Right? Which means that the changing y is 5, the change in x is 1, right? Because 5 over 1 equals to 5, which means that, let's just do a simple graph here, starting at 0, 0. So 2, 4, 6, 2, 4. Let's do red. So starting at 0, 0. Want to go up by 5 and go to the right by 1. So 1, 2, 3, 4, 5. Go up by 5. Go to the right by 1. We get to this point. This point right here. And yeah, just connect the line. Right, just like that. Okay, lastly now. Find the slope of the line that passes through E for -5 and F 8, 6. Right? So once again, we can plot this easily. But let's try to do it algebraically, because that one is just usually faster. So we're saying going from x -4 -5 should be like somewhere around here-ish. A6 will be somewhere up there. Again, just rough estimating it. So we're looking for, so this is point E, that's point F. So looking for the slope of line EF, right? That's the line that connects the 2 points. Okay, so we'll do the y value of this point subtracted the y value of that point. So it's 6 minus -5. X value of this point minus the x value of that point. 8 minus 4. 6 minus -5 is 6 plus 5, 11. 8 minus 4, 4. And just like that, that's it. So all we're doing here is to find, okay, how much is y changing? Okay, how much is x changing? Put it in a fraction, and that's our slope. Right? So with that being said, keep practicing and stay hydrated.